Hello and welcome to our lesson from Cleaner Air Tree by Tree. My name is Kelsey Desmond. I'm from Casey Trees, a local DC nonprofit with a mission to restore, enhance, and protect the tree canopy of the nation's capital. So we work in Washington, DC on a number of initiatives to increase canopy here. We plant trees all over the city and educate the public on the urban forest and the benefits it provides. I'm here with my colleague who I'll let introduce herself.
Hi, my name is Rebecca Davis. I work with Clean Air Partners. Clean Air Partners is a public-private partnership that educates the metropolitan Baltimore, Washington region about health risks associated with poor air quality. Welcome.
Thank you. So our organizations have partnered under an environmental literacy program and a grant with OSSE, the Office of the State Superintendent of Education. So thanks to the grant from them, we are able to provide this program, Cleaner Air Tree by Tree, which is a series of investigations on the urban forest and air quality and how they relate. This is the 4th out of 5 investigations, so you can follow along even if you haven't seen our previous lessons. Today, we are going to answer the question, how can I estimate the benefit of a tree on air quality? We will do that being tree detectives, looking for data about trees and air quality using a model. So put on your tree detective thinking cap. I just have on this slide as well the scarlet oak, which is the official tree of Washington, DC. It was selected in 1960. It is known for its brilliant red color in autumn. So I'd like to feature that tree first. So let's meet a tree. The first thing we'll do is to pick a tree to learn more about the benefits it provides. So why did we pick this tree? This tree shares characteristics with the DC state tree. So it's a cousin of this DC state tree. This tree is also the US national tree. So we figured we'd pick something that represents the US. It also has very common and distinct features of this type of tree. The features and characteristics are very unique, so you can know right away what you're looking at. It's also a very common tree in Washington, DC. So all that in mind, let's take a look and see if there are clues here that tell us what kind of tree this is. So you can use I notice, I wonder statements. I have an example here. I notice I sneeze when this tree starts to bloom. I wonder if I'm allergic to its flowers. Now this tree doesn't have big, beautiful flowers that you're thinking of, but instead has these really interesting and unique strands that come off the tree. So you can see the picture here. This flower is from an oak tree typically. These flowers then turn into acorns, this tree's fruit. And I know we love to eat fruit from trees, but we wouldn't necessarily eat all fruits from trees. But all trees have fruit that carry their seeds so they can make new trees. This tree's fruit is an acorn. Maybe you've seen acorns before. Also from oak trees, so we know that maybe this is an oak tree of some kind. Finally, we notice on this tree the distinct leaf shape. There are bristle tips and lobes on this leaf. So gathering all of that information about the tree, let's determine what species of tree this is. We can say this tree is a Quercus rubra or northern red oak. This tree has 2 names you've noticed, a scientific name and a common name. So why would a tree have a scientific name, and what language is that anyway? All species, both trees and animals, all different living things have a genus and species name. This is a scientific name that scientists all over the world would then know what tree they're talking about. So they would all know this tree's name is Quercus rubra. But we also give trees common names or nicknames that locally we can know what kind of tree we're talking about. So we call this the northern red oak. This tree, the oak tree, is a cousin of the scarlet oak, but also is a cousin of many, many oak trees. There are lots of species of oak. There are red oak cousins and white oak cousins. Both the scarlet oak and the northern red oak are a type of red oak tree. So now that we know a little bit better about this tree's species, and remember, humans also have a scientific name. Our scientific name is Homo sapiens. So now that we know a little bit about this name of this tree, what does this tell us about the tree? Why would we want to know the species? Well, we know we can gather more information about this tree based on the benefits it provides its ecosystem. So different types of trees provide different benefits to their ecosystem or community of living and non-living things. So let's gather some more information. I want you to think, what do you want to know about this tree? What would you measure on this tree if you were to meet this tree for the first time? And what information helps us identify the benefits that this tree provides its ecosystem? So I'll let you think about that. We'll take some measurements like arborists do. There are a set of measurements arborists take, or someone who studies trees, and then they put that in an inventory and use a model to determine benefits of certain species. An inventory would be a counting of a number of trees in a given area. You measure these trees to determine a model or to make a map, for example. So an arborist would measure this tree's height, kind of like you're measured every year at the doctor to make sure you're growing year after year. Arborists, when they take inventories, measure a tree's height. So let's see if we can measure this tree's height. I'm going to enlist the help of a fellow arborist, my friend Paul, and we'll use his height to determine the height of this tree using an approximate estimate. So we'll visualize stacking Paul on top of himself over and over, and we'll say that this tree is 5 Pauls tall. You can see I stacked him on top of himself to get to the tippy top of the tree. We know my friend Paul is about 6 feet tall, and this tree is 5 Pauls tall. So we're not measuring this tree in Pauls, but we'll measure it in feet by multiplying 5 by 6 and say that this tree is about 30 feet tall. Next, we would measure the trunk diameter, or the DBH, which is the diameter at breast height. This gives us a very central image of the trunk diameter. But what is the diameter? The diameter is a measurement of width on a circle from one end of the circle to the opposite end. And this would tell us about the relative age of the tree. Now, how could that be? The trees all over put a ring on themselves every year they're alive. They grow in width every year they're alive. Do you see the rings on this tree cookie? And if you were a tree, you might also put these rings on your body. So you can later do an activity where you take a paper plate and draw rings for every year you're alive. So I would draw 27 rings on my tree cookie. Maybe you would draw 10. You can even write your tree story on different rings, writing different events that happened on different tree rings. Trees are very similar. They bear their story on their rings. They've been around for a long time, for a lot of history, actually. So anyway, we would want to know about the relative age of the tree, how big it's going width-wise. So we wouldn't want to go through the center of the trunk of the tree. That would hurt the tree. There's another way we would calculate the diameter. We would normally take the circumference of the tree, or do we see this blue circle around the trunk of the tree, and then divide it by a number called pi, 3.14, to determine the diameter. So I have the equation on the right side of the screen. You can see diameter is equal to circumference divided by 3.14. So let's say you measure a circumference of 32 inches. You would say diameter equals 32 divided by 3.14. That would give you a diameter of about 10 inches. Finally, let's take 2 more measurements that are based on the tree's health and the resources that the tree is getting to survive or live. So we would determine the tree's exposure to sunlight. This tells us if the tree is getting everything it needs to survive. So we know that trees need sunlight to do photosynthesis or make food using light. So the tree, if it's fully exposed to sunlight and it needs a lot of sunlight, is getting everything it needs, most likely. Other trees do okay in shade, so they grow shorter or they need less sunlight to survive. Our friend the oak tree, though, needs lots of sunlight to survive. So if you look at the picture on the left, do you see any trees or buildings that would block the tree from sunlight throughout the day? I think it's getting full exposure to sunlight. Then finally, we would look at the tree's health. So let's look for some indicators or signs that tells us the tree is healthy or unhealthy. The two images on the bottom are examples of signs you would look for on a tree to see if it was sick. So humans also have these signs or symptoms. Sometimes we do things when we're sick to show doctors or other people that we're not feeling well. So an oak tree might have some leaf discoloration, so the leaves turn brown, or you can see in the picture on the right that the branches are losing their leaves and the leaves are turning brown. That's called dieback. So these are some sick oak trees on the bottom, but if you look at our picture, that's a pretty good looking oak. I would say that oak is in excellent condition. Let's use these measurements now to input into a model and see what benefits this tree provides. I'll hand it over to Miss Rebecca.
Thank you, Miss Kelsey. All right, so what we're going to do now is we are going to use iTree Design. And so you can see here the URL for iTree Design, but if you Google iTree Design, you also can find the link. And iTree Design is an app that is used to basically help us do an estimation of the benefits that an individual tree or a group of trees would provide. So once you get to the iTree Design, you need to choose whether you're using a laptop or whether you're using a tablet. So since I'm using a laptop, I've clicked on the laptop user. And then it says enter a street address below to get started. So what we're going to do is we're going to type in your address or my address. And as you can see, I've used this site many times, so it auto-populates. But you would have to actually enter your full address as well as your zip code. Once you do that, let's hit go. So it's going to bring us to a new interface. And what it's doing is it's loading two different structures. So one of them is this white frame, which is going to be independent from the Google map right here. So you can see this is the map that is populating. So what we're going to do then is, in case you want to play around with the map a little bit, you might get lost. You want to make sure you can use this plus sign, which will enable you to zoom in, or this minus sign to zoom out. Another thing I'd like to bring your attention to is this little tree icon, which we'll use to actually virtually plant out trees on our property. So the next thing, let's go to Place Trees, which is the second tab. And if you look at Place Trees, there's an area where it says Common. So if you remember, Ms. Kelsey talked to us about the common name for our tree. And it was the Northern Red Oak Tree. So you can see it has the common name, but it also has the genus Quercus and the species Rubra. So it has both the scientific name and the common name. So we're going to click on that. And if I remember the calculations, we had a tree diameter of 10 inches. So we're going to enter 10 inches here. And then lastly, Ms. Kelsey told us that the tree condition was excellent. Now, it's possible that the tree that you're going to be looking at is not in excellent condition. So you have the choice of different types of conditions here. And what are these tree conditions and tree exposure? So again, Ms. Kelsey told us that the tree that we were looking at was in full sun, right? One of the things that both the tree condition and the full sun enables us to provide the iTree Design is to tell us what kind of benefit, how much photosynthesis will take place and how much growth will take place within a year. So a tree that is in poor condition and does not have full sun will not grow as quickly and will not provide as many benefits. So now what we're going to do is we're going to go back to icon that I had told you about, and we're going to drag our icon and we're going to put it here in the courtyard of the building where I live. And then it brings you to information. It says confirm your tree information. Make sure that all the information is exactly what you had entered. And then you can click on OK. So now what we can do is we can go over to the model crown growth. And what you will see is the growth of the crown or the canopy of the tree will be growing over a period of 40 years. So you can kind of get a sense of how much shade that tree will give you on that property. Next thing we're going to do is let's go to estimate benefits. So an estimate benefits, it's asking you to enter the number of years. And what we're going to do is we're going to enter a nice round number, 10 years. And then we're going to go and press on calculate. So basically what the iTree Design app is doing is calculating for our tree, which is the northern red oak, the type of benefits that it will provide. So when we look at this new tab, what we can see is there are horizontal tabs right here. So we have stormwater, energy, air quality, and carbon dioxide. And then there are vertical tabs here. So total today, total from 2020 to 2030 for the 10 years that we had put in the previous frame. Future years, 2030, and then current year. So right now we're looking at overall benefits in the current year, 2020. So now what I want you to do is I want you to look at this pie chart. This is the pie chart because it looks like a pie. And I want you to, using the key, which is the elements right here, to tell me what is the greatest benefit that this red oak provides. What is the most amount of benefit, right? So when we look at the breakdown of this pie, we can see that air quality, or the color green, air quality, is what this tree really provides the most benefit, will be with air quality. And then the second will be this kind of lightish purple, will be carbon dioxide. And then the third will be stormwater. So this is for the current year 2020. As this tree grows, this is the benefits that it is going to provide. So the first thing we're going to do is we're going to go over to the tab stormwater. So then what we're looking at is trees, as you know, soak up a fair amount of water, and that is one of the big benefits. So we call that intercepting. So basically, intercepting is when a tree prevents the water from going to its final destination. And what would be the final destination? It would be Blue Plains for DC. Okay, different region, different water resource. So when you look at this tree, it says your 10-inch diameter northern red oak would intercept 574 gallons, right? That's a lot of gallons of rainfall and help avoid 199 gallons of stormwater runoff this year. So imagine we have not one tree in DC, we have 2.5 million trees. So that's a lot of, it's absorbing a lot of water. And that's really important instead of all that water rushing in the streets. So the next tab we're going to go to is we're going to look at energy, and we're not going to look at energy in depth. But one of the things we want to notice about energy is the fact that as this tree grows, and we saw it when we were doing a modeling of its growth over time, we could see that it would provide additional shade to this building, which means that these folks during the summertime would probably spend less energy because they'd be shaded by the tree. Similarly to when you're out playing soccer and you get overheated, you can go underneath the shade of a tree to kind of cool down. So next thing we're going to do is we're going to go over to air quality. So again, air quality current year. This is a different type of graph. This is called a bar graph. And again, you look at both the horizontal axis, which are all the different types of pollutants that we've talked about in past investigations. And then we also have here the amount of money saved, right? So here we're looking at ozone. So ozone is one of the criteria pollutants, and it is criteria pollutants that's often found during the summertime in cities, due in part to transportation or mostly to transportation. So here we could see that we would save $2 per current year. And then PM here is particulate matter 2.5, and you could see that you would save about $5.50. So what does it mean to save, and especially when we're talking about money? Basically, what we're saying is that the leaves of the tree, the stomata, the little cells that both where the gas exchange takes place, where it takes up the carbon dioxide and releases the oxygen, the leaves also take up pollutants. And so you can see here that this benefit from this 10-inch diameter northern red oak, it shows you that it would it's estimated that it would remove 0.6 pounds of pollutants, which means that it's that much less that humans around that tree would have to breathe. Now, again, remember, this is only one tree and we have 2.5 million trees. So the next thing we're going to do is we're going to look at carbon dioxide. Now, carbon dioxide is what we call a greenhouse gas, and a certain amount of carbon dioxide is important. So in the atmosphere, as you know, you'll find carbon dioxide, and it's important. It's like a blanket around the earth to keep the earth warm. So a certain amount of carbon dioxide is important. The problem is that since the Industrial Revolution, we've released too much carbon dioxide in the atmosphere. And so what's happening, it's like having too many covers in your bed, you get overheated. Same thing with the earth. The earth is getting warmer and warmer, and that's becoming a big problem. So trees are really important. Now, when the thing that happened is during the Industrial Revolution, not only did we produce more carbon dioxide, but we also cut down more trees. And so the action of those two, releasing more carbon dioxide and cutting down trees, has really increased the amount of greenhouse gases. So why is that? The reason is that trees actually sequester or take up carbon dioxide. So you can see that this tree, this northern red oak, will reduce the amount of carbon dioxide by 124 pounds. And it stores about 1,089 pounds of carbon dioxide. So what does it do with that carbon? So the carbon from the carbon dioxide is actually used to create cells in the tree to actually grow. So trees are made up of a lot of carbon. That's actually in great part what they are. So you can see on this chart here, sequestered or taking up, and these are the pounds. We measure carbon dioxide in pounds. For the current year, 120 pounds. So a couple other things about this graph or this app. So you can look at future years. We can switch. So for example, we can look at current year and total years. And what you'll see is that the vertical axis changes, right? This is from 0 to 140 pounds. And on this one, it goes from 0 to 1,800 pounds, right? So you need to really pay attention. And basically, over a 10-year period, this northern red oak will sequester a lot more carbon dioxide. Okay, so what we're going to do now is we're going to pass it back to Ms. Kelly, and she'll continue on.
Right. Thank you very much, Ms. Rebecca. Okay, so now we'll put all of this information together to determine our driving question. How can I estimate the benefits of DC's trees on air quality? So Ms. Rebecca did mention that we have 2.5 million trees in Washington, D.C., and they're all working together to take up air pollutants, soak up stormwater, and sequester carbon dioxide. So using the data we've gathered, we know that this tree soaks up or absorbs about 0.6 pounds of air pollutants. So you can say it would remove about 0.6 pounds. And if all of the trees made up together took that much out this year, in this year, we can estimate 0.6 times 2.5 million, so it'd be about half that amount, would be about 1 million pounds of air pollutants taken out of the atmosphere this year. That's a lot of air pollution that we're not breathing in, and that's not affecting our health. That does assume that all of the trees in DC are as old as our oak, do the same things as our oak, and are as healthy as this red oak. But trees do a lot for our atmosphere every year. I think I can happily say that we have minted all of you into tree detectives. So we have some other tree detective work for you. I took a screenshot from iTree Design of in 10 years, the benefits that this tree would provide. And this is adding together all of the benefits over 10 years. So taking a look at the graph on the left, do you see there's a line graph? Do you see the benefits increasing, decreasing, or staying the same over time? The trend on the graph is going up. So we can say that the benefits this tree provides is increasing over years. That, of course, assumes that the tree is in good health and is getting what it needs. So not only do we need to plant trees in DC, but we need to care for the trees that are already here so that they can continue to help us and our ecosystem. And you can see I made a little chart as if I had recorded the data from iTree Design. So over 10 years, this tree would intercept 7,472 gallons of stormwater. It would capture 1,615 pounds of carbon dioxide and absorb 7 pounds of air pollutants. And we remember these air pollutants are tiny and we can't see, so pounds of them is a really big deal. So now that we have new tree detectives, I have some detective skills for you to put to use. You can use iTree Design and use this model to imagine that this tree that you've measured is actually in poor condition or is not getting the exposure to sun that it needs. So do you think, and can you see, do the benefits increase, decrease, or stay the same over the years? And what about other species in DC? Do they provide the same benefits that the oak tree does? So we want you to put in the same data, but try a different species, such as the river birch, Yoshino cherry, or American sycamore, and see what these species provide to us. And I have to say, iTree is a wonderful model, but it doesn't always capture every benefit that trees provide. I know, for example, that Yoshino cherries have beautiful flowers in the spring, or that the oak tree, while it does have these benefits quantified on iTree, has other benefits like providing homes for over 200 species of butterflies and birds. Finally, you can write your story as a tree, like I was saying earlier, with your tree cookie. So you can create a tree cookie for your life and read an article about how tree rings are impacted by major events in the environment. Or you can write us a poem about how much you love trees. Miss Rebecca and I actually have an email address that we check looking for tree stories and looking for tree detective sleuthing. So if you'd like to do these assignments and send us your work at cleanerairtree-by-tree@gmail.com, we would love to answer any other questions you have. Thank you for joining us for this lesson. If you have questions, let us know. Hope to see you soon.
Bye.
Bye.